So you can see that. Okay. So this is the condition for discrete time signal. Okay, this is the condition for discrete time signal, and here you have this n as a number of sample. Okay, it is a number of sample, 10 or 2 or 3 or 5, any number of samples. Okay, so we will try to find one try to find a period. Okay, so can you try this question? Okay, can you try this question? Find, okay, no, 2 e to the power j omega naught n. Okay, say let's say this is xn. Okay, I will write it here again. Okay, so this is one question. Okay, so can you try to prove if we have a signal xn, it is a exponential signal. Okay, e to the power j omega naught n. Okay, is a periodic signal, and what is the period? So I think we have done this in case of continuous time signal. So I hope you can do this. Okay. The only difference is that instead of t, here we have n. That is the only difference. Okay. So can you try this, please? Okay. Can you try this? May I give you some time? Two or 3 minutes. So you have to apply this condition to be periodic. Okay, the signals to be periodic, we have this condition n plus capital N should be equal to xn. Okay, so this is the condition. Okay, so try to apply this condition and try to find this n. Can you just try it and tell me what is the n? So if anyone can do this, can you raise your hand at least? Actually, I want you to be active here. Okay. So can you just at least raise hand? I'm not going to ask any question. If you can do this, okay, if you can do this, if you, at least if you feel you can do this, can you raise your hand, please? Okay, in reaction, there is a hand raise or something. Okay. So what about Dilan, Sasika, Piyumal, Araga? Anyone? This is, we have done these things, no? Earlier, in case of continuous time signal. So you should be able to do this, I hope. Okay, I will do it for you. Okay. So you can see that this is a condition. Okay. So keep remember this. Okay. So this can be these things, this type of question will come to your exam also. Okay. So pay your attention and try to understand. Okay. If any problem, you can just post me and ask. Okay. Okay. So I will evaluate this. Okay, so here we have xn e to the power j omega naught n. Okay, so we have this signal. So what is this? This is exponential signal, no? Okay, so if we have draw this signal, how it look like? How it look like? This exponential decay signal, no? Complex exponential signal like this, no? This is the signal, no? Okay. So this kind of signal we will get, okay, continuous. But here this is discrete, so we will get uh, some sample like this, okay, like this. Here for this we have some sample like this, okay, like this. So this kind of waveform we will get, okay. So how to find the how to prove this is periodic or not, okay. So if it is periodic, this condition should be satisfied. That means xn plus capital N should be equal to xn. So I can simply apply this condition here. Okay. So how can apply? Okay. So e j omega n, e j omega naught n should be equal to e j omega naught n plus capital N. Okay. So here instead of n, I can just substitute n plus n plus n. Okay, so we have to prove this. Okay, we have to find whether this is correct or not. Okay, so simply you can do this, no? So here you have j omega naught n is equal to, so you can see that this is the summation is there. Okay, so you can do it you can write it as a product here. So it is j omega naught capital N e j omega naught n. Okay, so what should happen if this one and this one to equal this one and this one? Okay, this one and this one, what is the condition here? So this is xn, okay, and this part is xn plus capital N. Okay, so anyone can tell me if this two is equal, if this two xn plus n to be equal, okay, what's happened here? Okay, what's happened here? What happened here? So to equal this part and this part, so you can see that here we have this term e to the power j omega naught, and here also e to the power j omega naught. So to be equal, these two sides in this equation, what should be the condition? What's about this one? This one should not be here, no? This term should not be here. Can you understand it? This should be 1. Then this part and this part, this equation will be equal, no? This part and this one will be equal. If this e to the power j omega naught capital N is 1. Okay? Did you get it? If you didn't get it, just tell me, okay? Then I can explain it simply. Okay, so what happened to satisfy this condition? E to the power j omega naught n should be equal to 1. Okay, so this is the condition. So here we have a j omega naught n should be equal to 1. Okay, so we have to find this is true or not. No, this is true or not. If this is not true, what is our conclusion? If this if this condition is not true for any n value, okay, what is our conclusion? If this is not true, what is our conclusion? That means this condition cannot be satisfied, no? If this is not true, if this e to the power j omega naught n is not 1, okay, that means this condition cannot be satisfied. If this condition cannot be satisfied, what that mean? What it mean? This is not periodic, no? This is not periodic. Okay. So if this condition is true, what is happen? If this is true, if this e to the power j omega naught n is equal to 1, okay, for any value of n, okay, that means at that value, at that n value, this condition is true. Okay, this condition is true. Then if this is true, okay, if this is true, if this is true, if this is true, okay, that means this condition is also true. No, that means what is this condition? If this condition is true, that means we can say that it is periodic. No, I hope you get it. Okay, I hope you can get it. So we will continue. Okay, so what we have to do, we have to find any n value is there that satisfy this condition. Okay, so here we have aj omega naught n, and it is equal to 1, and we have to find any n value that is equal, that is satisfy this condition. Okay, so if I so you know that e to the power j omega naught n is equal to this. Using Euler formula, we can write it in terms of cos and sine function. Okay, so we have cos j omega naught capital N plus, okay, j sine. So here, sorry, here j is not here. Okay, omega naught n, omega naught n plus j sine omega naught n. Okay, so we have these two value. Okay, so if I write the sine, if I draw the cosine wave, it will look like this. You already know this. Okay, and here it is 5. Okay, and here it is 5 by 2. Okay, and here it is 3 5 by 2. Okay, and here it is 2 5, so on. Okay, and if I draw the sine wave, it is look like this. Okay, and here it is 5. Okay, and here it is 2 5 3 5, so on. Okay, and here this point will be 5 by 2, like this. So this is sine wave. Okay, and this is cos wave. Okay, so to satisfy this value, okay, to satisfy this value, so you can see that it is a complex value. So this, if this complex value should be equal to 1, what happened here? It is a simple question. I think you can answer it. What this part should be what? If this is equal to 1, this part should be what? It is 1. Okay, it is 1. It should, oh, sorry, it should be 0. Is it okay or not? Yeah, it should be 0, no? Okay, so if this is 0, and if this cos omega n is equal to 1, this e to the power j omega naught n will be equal to 1. Okay, okay, so the condition is that this should be 0. The first condition is that this should be 0. Okay, so you can see in sine wave this 5 2, 5, 3, 5, all values are 0. Okay, so you can see that this if this n, okay, so we have to get the whole 2, no? So this n omega naught is equal to, okay, if we get sine value, I think you should understand these things. Okay, so sine omega naught n, okay, omega naught n should be 0. Okay, so what point this should be 0? At sine 5 it is 0, sine 2 5 0, sine 3 5 0. No, that means here omega naught n, okay, omega naught n should be 5, then sine 5 will be 0, and omega naught n is 2 5, then also sine 2 5 is 0, then omega naught n 3 5, that also sine 3 5 is 0. Here we have 0 0 0 for this value. Okay, so this omega naught n, if this omega naught n is equal to 5 2 5 3 5, okay, what happened? So this is 5 and this is 2 5. Okay, and this is 2 5, this is 4 5, and this is 5 4 5, this is 3 5 by 2, and this is 3 5. Okay, and this is 5 by 5 5 by 2, and this is 4 5. Okay, this point we have marked it wrongly. Okay, so here should be 0 0 0. Okay, so you can see that if omega naught n is equal to 5 or 2 5 or 3 5, this omega naught n, sorry, sine omega naught n will be 0. Okay, so you can see some value for n, this value is 0. Okay, and also you have to select some value. Okay, meanwhile this is 0, this should be 0. At the meanwhile you should see some value, this 1, this cos omega naught n is equal to 1. Okay, so you can see that at 5 omega cos omega naught n is not 0. No, cos 5 not 0, it is -1. But you can see at 2 5, okay, cos omega naught is 1. Okay, cos omega naught n is 1. Okay, so you can see that if you consider cos 2 5, okay, cos 2 5, it is 1. Okay, and you can see that sine 2 5, it is 0. So you can say that at first, okay, at 2 5, okay, if this omega naught n is 2 5, okay, you can see that e to the power omega naught n is equal to cos omega naught n, that is 2 5, j sine omega naught n, that is again 2 5, and you can see that sine 2 5 is 0, cos 2 5 is 1, then e to the power j omega naught n is equal to 1. Okay, so you can see that this condition is true. Okay, this condition is true. We have several n value, no? Okay, so omega naught n is equal to 2 5 4 5, then 6 5. All these point, this condition is satisfied. So we have some n value, omega naught value. Okay, so you can see that we have some n value, no? We have some n value. We have some n value that satisfy this condition. Okay, that is, this whole terms should be 2 5 4 5 6 5, so on. Okay, so the fundamental period is the minimum period. Okay, minimum duration, always minimum duration. Okay, fundamental period is minimum duration. So you can see that if this is the fundamental period from here to here to 5, okay, and 4 5 it is also repeating. No, at 4 5, if you consider the 4 5 time period, and after 4 5 it is repeating, but we are not considering this 4 5 as the fundamental period. We are considering the minimum distance, minimum time level as the fundamental period. So what is the minimum value here is that 5. Okay, so you can see that. Okay, so you can see that at omega naught n, okay, omega naught n is equal to 5, that condition is satisfied. That means xn plus capital N is equal to xn. This condition is also satisfied. That means this signal is period. Okay, and the period is normally this n value we consider as period. So n will be 5 by omega naught. Okay. So that is how we can find this answer. Okay, that is how we can find this answer. Okay, so you can see that answer to this question. What is the answer to this question? Yes, this e to the power j omega naught n is periodic. Okay, so our answer is that e to the power j omega naught n is periodic, and the period is n. Let's say it is n naught. It is 5 by omega naught. Okay, so we have proved this. Okay. So we have done this several times in our continuous time signal. Okay, the same procedure we have followed up. Okay. So as a homework, okay, so try to do this one. Okay, I hope if you can mail me, I like. Okay, if you can if you can please try to do this and mail me the script, then it is better, then I can evaluate it. Okay, so try to prove cosine, okay, cosine omega naught n plus theta is periodic signal, and period is 5 by omega naught, capital N naught. Okay, so try to do this, try to find the period of this cos omega naught n plus theta signal. Okay, so you have to use that condition, n plus capital N is equal to xn. So you can simply add this and try to do some simplification using trigonometric identity. Sometimes you can use the Euler formula and convert this to a exponential terms, and sometime maybe you can do the evaluation. Okay, using this as a known fact. Okay, using this result as a known fact, you can evaluate, and you can evaluate directly evaluate without using this exponential terms things. Okay, you can also directly evaluate this. Okay, but you have to prove that cos omega naught n plus capital N plus theta should be equal to cos, okay, cos omega naught n plus theta. So using trigonometric identities, you can expand this and try to do some mathematical simplification, and I hope you can come to, you can evaluate this fundamental period for this signal. Okay. Okay. So now we will go to our Fourier series representation. Okay, Fourier series representation. Okay, again, so we know the Fourier series coefficient, so Fourier series representation. This is okay. So this is to have. So we will do one example to use this one. Okay. So so this is the example. Okay, we have to determine the Fourier series coefficients for this periodic signal. So you can't see my screen, no? Now you can see, no? I have one waveform, discrete time signal waveform. Okay, we have one discrete time waveform. This one, okay. So this is xn. Okay, this is xn, you can see it. So we have to evaluate the Fourier series of Fourier series representation of this signal xn. Okay, Fourier series representation. So first try to find the n, that is the period number of sample. Try to find this n. Let's say this n naught. Okay, first try to find the n naught and try to find one or two coefficients by yourself. Okay, so I will give you 5 minutes. Okay, I will give you 5 minutes and I will leave the session. Okay, so that you can talk with yourself and discuss with yourself, with your group, and try to evaluate this. Okay, you can ask. Okay, because in examination I can see that you ask your friend to show their answer script. So same way you can ask how this is solved. You can ask that friend, how can this solve? මේක කොහොමද විසඳන්නේ? Okay. හරි මම මේ ලිව් වෙන්නම්. ඒතකොට කට්ටියට බයිනෝක කතා කරහැගෙන. මම ලිව් වෙලා අපෝ